Good day, everyone. Yesterday we had a lively discussion because many of you were participated. Let us see now if you can still recall those things by answering the following questions. First, what is chemical formula? Second, what are the rules in writing chemical formula? Take a look at the given picture. These are the materials around us. Can you name some of the objects in the photo? Can you say what they are made of? If we take a look at the materials around us, we find great variations in their properties. The materials in our world present a striking and seemingly infinite variety. Yet, there are about 118 elements and therefore 118 kinds of atoms that give rise to this diversity. In a sense, the atoms are like the 26 letters of the alphabet, which join together in different combinations to form the immense number of words in our language. This next picture shows the crowd of people. If you will be given the names of the people present here, how long would it take you to memorize all the names? Likewise, there are now over 13 million known chemical substances. Naming them all would be a hopelessly complicated task if each had a special name independent of all others. Fortunately, naming chemical compounds is much easier because chemists formulated systems or rules in naming chemical compounds. Today, we will be dealing with the naming of chemical formulas. As we go along to this topic, you are expected to explain the rules in naming chemical compounds and follow the rules in naming chemical formulas. But first, let us define chemical compound. Chemical compound is composed of two or more elements united chemically in a definite proportions. We have two types of chemical compound, the binary compound and the ternary compound. Binary compound are compound consists of two elements, while ternary compound are compounds that consists of three or more elements. We have the rules in naming binary compounds. First, binary compounds containing a metal and non-metal. Give the name of the positive element, which is metal, followed by the name of the negative element or non-metal with the ending IDE. For example, here in this compound MgI2, we will first give the name of the first element, which is Mg, and that is magnesium, followed by the name of I2, which is iodide. Another example is LiF. Again, we will give the name of the metal Li, which is lithium, followed by the name of the nonmetal that ends in IDE, which is fluoride. For the binary compounds containing two nonmetals, they are named using Greek prefixes to indicate the number of each of the atoms present in the compound. For one, we have mono, two, di, three, tri, four, tetra, five is penta, six is hexa, seven is hepta, eight octa, nine nona, and 10 deca. The prefix mono is omitted in the first element. The ending IDE of the second element is also used. Nitrogen, sulfur, and phosphorus are common nonmetals which form several compounds with oxygen and other elements. For example, for this compound NO, notice that we only have one atom of nitrogen. According to the rule, we do not use the prefix mono for the first element. Thus, we have to give its name as nitrogen. On the other hand, the second nonmetal, which is oxygen, has also one atom, but in this case, we will be using the prefix mono, indicating that there is only one atom of oxygen in this compound, and it is followed by the name of the nonmetal that ends in IDE, which is oxide. Hence, the name of this chemical compound is nitrogen monoxide. Another example for this compound, we have CCl4. Here, we only have one atom of carbon. Thus, we will not use the prefix mono for the first element, and we have its name carbon. For the second nonmetal, notice that we have four atoms of chlorine. Therefore, we will be using the prefix tetra followed by the name of this nonmetal Cl that ends in IDE, which is chloride. Hence, the name of this chemical compound is carbon tetrachloride. The third rule is binary compound containing metals with variable oxidation numbers. Here, we will give the name of the metal followed by the Roman numeral in parentheses to indicate the oxidation number, then give the name of the nonmetal in the usual way. However, an older method is still commonly used in which the suffixes OUS and IC to indicate the lower and the higher oxidation numbers or valence respectively. For example, for this compound FeCl2, we will give the name of the first element, which is iron in this case, and the oxidation number used by iron for this compound. We already assume that the iron and chlorine here already done the crossover of their oxidation numbers. So therefore, the 2 subscript of chlorine here came from iron, and the 1 here of iron came from chlorine. So the oxidation number used by iron here is 2, followed by the name of the nonmetal that ends in IDE, which is chloride. Therefore, the name of this compound is iron 2 chloride. Another name of this compound is ferrous chloride. Why ferrous chloride? Since that we only have 2 valences for iron, we have iron positive 2 and iron positive 3. So iron positive 2 is lower than iron positive 3. So therefore, we will be using the suffix OUS for lower oxidation number. In this case, we will be using also the Latin name of the metal, which is ferrous, and then followed by the name of the nonmetal that ends in IDE, which is chloride. Hence, the name of this is also known as ferrous chloride. Another example is Pb3N4. Again, according to the rule, we will be give the name of the first element, which is lead, followed by the oxidation number used by this element written in Roman numerals and enclosed in parentheses. Again, in this case, the crossover of oxidation numbers between the two elements was already done. So the 4 here, a subscript of nitrogen, came from lead, and the 3 here, a subscript of lead, came from nitrogen. So therefore, the oxidation number used by lead here is 4, followed by the name of the nonmetal that ends in IDE, which is nitride. So therefore, the name of this compound is lead 4 nitride. On the other hand, the name of this compound is also known as the plumbic nitride. Why plumbic? Since we only have two oxidation numbers for lead, and those are Pb positive 2 and Pb positive 4. Since positive 4 is higher than positive 2, therefore we will be using the suffix IC, followed by the name of the nonmetal that ends in IDE, which is nitride. Therefore, we have the name plumbic nitride. Another example, we have CuS. Notice here that we don't have the written subscript for Cu and S, but the name of this is copper, followed by the oxidation number used by copper, which is 2. Why 2? Since that sulfur here has an oxidation state of -2, according to the rule in writing of chemical formulas, the oxidation numbers of the two elements are the same, so we will just cancel it and combine the two. Since that there are no subscript written beside copper and sulfur, so we assume that copper here has an oxidation state of positive 2. Therefore, the name of this is copper 2, followed by the name of the nonmetal that ends in IDE, which is sulfide. So we also know this compound as cuprous and cuprous sulfide. The next rule is binary compounds containing hydrogen. When binary compounds of hydrogen and nonmetal are present as a liquid or as a gas, they are named as other compounds of nonmetals. For example, for this compound HCl, which is in liquid form, we will be giving its name as an ordinary binary compound. So we will give the name of the first element H as hydrogen, followed by the name of the second element, which is Cl, that ends in IDE, and in this case is chloride. Thus, the name of this compound is hydrogen chloride. Another example is HI. So in HI, it is also in liquid form. So therefore, we will give the name of the first element H as hydrogen, followed by the name of the second element I that ends in IDE, which is iodide. Therefore, the name of this compound is hydrogen iodide. However, when binary compounds of hydrogen and nonmetals are dissolved in water, different names are used for water solution of these compounds. Since they give acid solutions, they are named using the prefix hydro, followed by the stem of the name of the nonmetal with the suffix "ic", and the word acid is added. For example, for this compound HCl in aqueous form or in aqueous solution, we will be giving its name using the prefix hydro plus the stem of the name of the nonmetal, which is chloro, and we will add the suffix "ic", and the word acid is also added. So therefore, the name of this compound HCl in aqueous solution is hydrochloric acid. Another example is HI, which is also in aqueous solution. Again, we will use the prefix hydro plus the stem of the name of the second element I ayodo, and the suffix ic, should I say, is added. Therefore, this will become iodic, and the word acid at the end is also added. So therefore, the name of this compound is hydroiodic acid. For the rules in naming ternary compounds, the first rule is give the name of a metal followed by the name of the polyatomic ion or radical. For example, for this compound MgOH2, we will give first the name of the first metal Mg, which is magnesium, followed by the name of the polyatomic ion OH, and that is hydroxide. Therefore, the name of this compound is magnesium hydroxide. For the second compound, Al2SO43, we will give again the name of the first element or metal, Al, and the name of it is aluminum, followed by the name of the polyatomic ion SO4, which is sulfate. Therefore, the name of this compound is aluminum sulfate. The second rule in naming ternary compound is, in the radicals or polyatomic ions combined with hydrogen ion in water solution, they are given different names. The ending ATE of the polyatomic ion is changed to IC, and the word acid is added. If the ending of the radical is ITE, it is changed to OUS and the word acid is also added. For example, in this compound H2SO4, since SO4 is a polyatomic ion that ends in ATE, therefore, we will just change this ATE into IC and the word acid is added. Hence, the name of this compound is sulfuric acid. For this compound H2SO3, this SO3 polyatomic ion ends in ITE because this one is sulfite. According to the rule, if the polyatomic ion ends in ITE, it will change to OUS and the word acid is also added. Therefore, the name of this compound is sulfurous acid. The third rule in naming ternary compound is the acid containing still less oxygen has the prefix hypo and ends in OUS. For example, this compound H2SO2. Notice that SO2 has the number of oxygen which is 2 and is lesser than the usual polyatomic ion SO3. Hence, we will be using the prefix hypo plus the stem of the name of the polyatomic ion that ends in OUS and the word acid is also added. Therefore, the name of this compound is hyposulfurous acid. The fourth rule in naming ternary compound, the acid containing one or more atoms of oxygen has the prefix pair and ends in IC. For example, we have H2SO5. Here, SO5 has one more atoms than the usual SO4. So therefore, we will be using the prefix pair followed by the stem of the name of the polyatomic ion that ends in IC plus the word acid is added. Therefore, the name of this compound is persulfuric acid. The last rule in naming ternary compound is the compounds of metals with variable valences and polyatomic radicals are named just like a binary compound. For example, FeSO4. Knowing that Fe or iron has variable valences such as +2 and +3. So again, we assume that this compound already cross over their oxidation numbers. Sulfate has an oxidation number of -2, while iron here has an oxidation number of +2. So therefore, the oxidation state used by iron here is +2. Thus, the name of this compound is iron followed by the oxidation number used by iron, which is in open parentheses and written in Roman numerals, that is 2, followed by the name of the polyatomic ion, which is sulfate. Therefore, the name of this compound is iron 2 sulfate. Or we could also name this as ferrous sulfate. Since this is +2 and is lower than the oxidation state of iron as +3, therefore we will be using the suffix OUS, and the name of this is ferrous followed by the name of the polyatomic ion SO4, and that is sulfate. Thus, the name of this is also known as ferrous sulfate. Now that we're done discussing the rules in naming binary and ternary compounds, try giving the name of the following compounds. P4O6, Na2MnO4, PbC2O4, Cr2O3, and AsCl5. Thank you and see you next time.